morning, everyone. Thank you, Valerie. I'm Yoshihiro Toriumi from Tokyo Denki University, Japan. Thank you for inviting me. I will be giving a presentation on this topic. Okay. This is the contents of my presentation. Japan is a country with currently about 123 million inhabitants. This figure shows the area of construction started in Japan. Housing, offices, stores, factories, and workshops, etc. Okay. In Japan, in 1992, as a standard in cold regions, a house with equivalent leakage area of 5 square centimeters per meters or less was defined as airtight house. In 1999 revised notification, the ELA F9.8 was divided into areas with 2 or less and areas with 5, and became nationwide specifications. In 2003, this was enacted, and revision to the building standard law mandated the installation of mechanical ventilation equipment as a countermeasure against sick house syndrome. In 2009, the standard value for building airtightness was deleted, based on the judgment that the airtightness of housing was widely known and construction was being carried out. However, in 2020s, some local governments began to establish and satisfy standards for building airtightness. In Japan, ELA F9.8 is used as an index of airtightness. ELA F9 is calculated by jointly establishing equation 1 and equation 2 with a pressure difference of 9.8 Pascal and dividing the result by the floor area. Conversion table for each airtightness performance indicator. ELA F9.8, QE50, and HH50. Separate calculations are made for detached houses and multifamily dwellings. Currently in Japan, there are no national building airtightness requirements in the regulation. On the other hand, local governments are making efforts to improve airtightness. As shown in the table here, each local government, Sapporo, Yamagata Prefecture, Nagano Prefecture, and Toto Prefecture, has similar standards. But Sapporo has stricter standards due to its cold climate. Local governments set standards for building airtightness in addition to standards for insulation, and partially subsidize construction costs. Airtightness tests are not mandatory, but it must be done in accordance with GS 2201 in order to receive subsidies for construction costs from local governments. Airtightness measurements are performed by airtightness measurement technicians registered by IBEX. Airtightness tests are not compulsory, so there is no penalty. Okay. In Japan, there is an evaluation program for energy efficiency and conservation standards for residential and non-residential buildings, but there is no input item for building airtightness. This is based on the judgment that the airtightness of houses is well known nationwide and that construction is being carried out. IBEX is conducting a training project for building airtightness measurement technicians for houses. Those who have mastered the measurement method based on GIS-A 2201 are considered airtight measurement technicians. About 500 people pass the exam every year. There is no official data available for building airtightness testing. In Japan, it is common to measure the building airtightness of houses, and non-residential airtightness measurements are rarely performed except for special buildings. Okay, this figure shows changes in the building airtightness of dwelling units in housing complexes by the authors. ELF 9.8 and QE50 shows. The QE50 of dwelling units around 1970 is about 5 cubic meter per hour per square meters. After retrofit and before retrofit. The QE50 of dwelling unit after 2000 is less 1 cubic meter per hour square meter. Approximately HEH50 is 1.5. On the other hand, airtight retrofitting of stock buildings will be around openings, and the QE50 are improved to about 3.5 cubic meter per hour per square meter. Approximately HEH50 equal 4.5. This figure shows the relationship between building airtightness and the airflow exponent N for 233 detached houses from 2015 to 2020. Over 50% of detached houses have QE50 of 1.7 cubic meter per hour per square meter. Approximately HEH50 equal 1.5 or less. The airtightness of multi-family dwellings can be improved by airtight retrofitting around openings. However, detached houses require airtightness improvement over the entire house, and it is important to create an air barrier. Okay. AIJ is currently formulating academic standards to improve building airtightness of houses. In addition, a consortium study group on building airtightness of non-residential buildings have been established. This shows an example of table of contents of AIJ-ES. building airtightness performance standards, plant ventilation and building airtightness, improvement of thermal environment and heating and cooling energy consumption through building airtightness retrofit, required building airtightness and achievement airtightness standards, building airtightness and openings evaluation methods, methods of measuring building airtightness performance, installation position of air barrier and condensation inside the wall, building airtightness and problems, etc. Conclusions. Japanese buildings ensure a certain degree of building airtightness. The awareness on building airtightness in Japan is growing again, but there are still very few non-residential buildings that are tested. This is probably because airtightness testing of non-residential buildings is difficult. However, research consortium have started up, and it is expected that interest in building airtightness for non-residential buildings will increase in the future, and databases will be created. In the case of housing, local governments are setting standards for building airtightness in some cases, and the number of airtightness testers is also increasing. Ductwork airtightness. In Japan, the ductwork airtightness has not been really considered so far. This is no national regulation nor guideline on this subject, so there is no requirement on the airtightness level of ductworks. Ductwork airtightness is important for ventilation and energy saving, but there are only rare cases in which clients request a ductwork airtightness test. Thank you for your attendance. Thank you very much.